Now we will start with the SOC standard, and first some terminology and then lexical elements in this today, and later we will talk about details about the other parts of the standard. But throughout the course I will mention various things as they are suitable to discuss. Okay, so the C standard, there is an important word called the implementation, and the implementation is the C compiler and the standard library with functions such as printf or malloc. These two together is called the implementation. We can, if we use assembler, use only the standard library, but then we are not programming in C, but it's possible. So we can use the library without the C compiler, and we can use the C compiler without the library, but then we can only use, well, anything except the library functions. So if we want to do something useful, we typically would have to write basic IO function ourselves and use the system calls. There is a system call for reading and writing, for instance, to a file or somewhere else. Okay, but using only the system calls of an operating system is non-portable, obviously, since the functions have different names on different operating systems. Usually Mac and Linux have the same names since they are Unix versions both. But Windows have completely different. Okay, so we want to use a C compiler and this standard library. Then there are requirements on the source code, what it is allowed to look like, and there are requirements on well, first of all, the semantics, how should the compiler translate this code, such as a for loop. But there are also requirements on what the compiler must complain about and what it is not forced to complain about. I mean, when there are errors. Okay, so in the standard, when something is described, it can say that this is a constraint, and then it must be checked at compile time. An example is if we forget to declare a variable or have a syntax error. So when we see that it must be diagnosed, it does not mean that if there is an error, that there is a specific way how this complaint should be made. There is no such thing as error message or warning message in the C standard. It's only called compiler diagnostic message, and how they are done, it's up to the compiler to do. Okay, let's look at an example, namely of loops. So this is called iteration statements, and there are basically three kinds of loops. Well, there are two different for loops here, but they are basically the same. So here we can say, see that the constraints, the controlling expression of an iteration statement shall have scalar type. Okay, so if we don't, then the compiler is not only allowed, it must complain. So if we have while and this expression is the name of a struct variable, it must complain. If we write an array here, the name of an array, then you may say that's not the scalar type. But it's actually possible, since this array name will be converted to a pointer at this point. So it's still a scalar type. Okay, so the constraints must be checked, but there are other problems in the program which must not be checked. For instance, divide by 0 or using an invalid pointer. Three important words: implementation defined behavior, unspecified behavior, and undefined behavior. They are almost guaranteed to come to the oral exam. Okay, so C is used for small embedded systems and up to supercomputers. So in some sense, it makes sense to let the compiler or the implementation use different sizes of integer types to more fit the environment. Okay, so examples of implementation defined behavior is the size of an int. It must be at least 16 bits, and usually it's 32 bits. But compare that to Java, where Java defines it to be always 32 bits. Okay, there are other things. So, for instance, how right shift is done, if that is a so-called arithmetic shift or a logical shift. We will come to that later. In Java, it's defined to always be arithmetic shift. There is a logical shift in Java, but then you have to use 3 greater than characters. Okay, so implementation defined behavior, it must be documented in the compiler. I mean, in the compiler's documentation, it must say what is the size of this, how is that done, and well, so we can rely on that. Say we now want to write a portable program and we don't know the size of an int. Of course, we can still use C. And there is a header file called standard int, which defines integer types of various sizes. So this one would typically be a signed car, signed short, signed int, and signed long or signed long. And then there are unsigned for the respective types. These types are not compulsory to be present in the compiler, in not the compiler, but in the standard library. If we have a compiler for digital signal processing unit, then we may not have 16 or 32-bit integers, maybe instead 24-bit integers. So we cannot be sure that these exist. But if the type, I mean the int, if there are 16, 32 and 64-bit integer types, then these must be available as well. And they usually are for normal machines. Unspecified behavior. Okay, so the important difference between implementation defined behavior and unspecified behavior is there are two things. First, in unspecified behavior, the compiler, what it decides to do is not necessarily documented, or it's not documented what it does. Well, it's not forbidden to document it, but it's not a requirement. And the reason for that is that the compiler can decide differently in different situations. A typical example of that is the order of evaluation of operands to add. Okay, so we don't know if F or G is called first, and clearly the output will depend on which is called first. And which is best to call first? Well, that's up to the compiler to determine and decide on its own without informing anyone. It can be different days, but usually compilers are as deterministic as possible, otherwise it's hard to debug them. Okay, another example of unspecified behavior is the order of evaluation of parameters. So it's not at all the first, second, third, etc. parameter. It can be in any order. And the reason for that is we can select a smarter order in order to reduce the number of registers that will be needed. Okay? Undefined behavior, that's really an ugly form of bug. And this occurs when we use something that violates a rule in the standard that is not a constraint. Meaning the compiler is not required to check it and complain. Examples, well, that's what I just said. For instance, that we have a pointer that is invalid, or we use a local variable before it's given a name, is no, but the value, and divide by 0 for integer types. Sometimes also for floating point types, but usually not. Usually floating point divided by 0 results in a defined value in all modern machines. Okay, it either becomes not a number if we have 0 divided by 0, or infinity, or minus infinity. Okay, if we are array index out of range, then it's also undefined behavior.